Hello, and welcome back to Let's Learn C. Last video we did our Hello World. We learned a few things. argc, argv, placeholders, header files, and how the compiler works. Not really how the compiler works, but what it does. It compiles it into assembly and then into a binary, which is different for every OS. So let's get on to the next thing, which is a temperature converter. So I'll say we've done the first step. Let's move on to step 2. I keep allowing it ls, but I don't know why it keeps asking me for permission. It's definitely in here. Okay, cool. Temperature converter is already there. Okay, so why are we doing it? It's a great second project because it introduces 3 new building blocks at once. Variables and types. Int, float, double. Okay, scanf is the basic way to read user input. It's the counterpart to printf, but trickier because you pass a pointer to where the data is stored. And then there's arithmetic. Fahrenheit to Celsius. Okay. Subtle trap. If you do 5/9 with integers, C truncates to 0. This is integer division, something JS devs never worry about. Okay. We're going to create temp.c here. And I'm going to try to remember not to move this window because the last video I moved the window and QuickTime, which is recording, didn't move the viewport of the recording with the window. And so half my, well, not half, but a whole bunch of the sidebar got cut out. All right, so we're going to include the same header file as last time. So standard input output.h. Feels good that I can type that and understand what I'm typing. That's cool. Okay. All right, so we're back. I tried to get a formatter. I tried to use Prettier, but the Prettier doesn't have a C plugin, so I'll figure out formatting later on. All right, let's move on and get into what we're building today. So there's a main function, that's done. A variable to hold the input, try double. It handles decimals. Okay, a variable to hold the input, try double, it handles decimals. So I guess it's like double my variable. Equals 0.3, I guess. A variable to hold the input. Printf to prompt, scanf to read, printf again to show the result. Okay, so printf, enter something. Here I go again without putting in the semicolon. Scanf to read. So what is scanf? Scanf. The format specifier for double is %lf, not %f. That's for float. And you need to pass the address of your variable, like scanf blah with blah. Okay. First, tell me how scanf works. I don't have any plugins. Maybe I should reinstall the C plugins just so I can see what it does. So it reads standard in from the terminal, passes it according to a format string, and stores the result into a variable. It's basically the input counterpart to printf. Okay. So my double variable is here. Printf just enter something. Scanf. The first argument is a format specifier. So let's say %lf, and we're passing in the address of. Okay. In JS, you just do let temp. I'd never write let. I write const, but okay. Equals read input and get a value back. See, scanf works differently. Instead of returning the value, it writes directly to a memory address you provide. So the and temp means the memory address where temp lives. So we've declared my variable here. If I did and my variable, this is telling it to look at the memory address where this variable lives. You're handing scanf a location to put data. Think of it as passing a mailbox address versus passing the mail itself. This is your first taste of pointers, which you'll dig into fully in your project 4. So instead of instantiating this, I'm guessing that we're taking in whatever input, which we're expecting to be an LF, which is a type double, and we're going to put that into my variable, or the address where my variable is, which has already been declared up here. Interesting. Okay. Scanf returns the number of items it successfully read, so you can check if the read worked. So, okay. So yeah, we could declare a result of integer and read the result of the scanf operation. Why does C do it this way instead of just returning the value? Because scanf can read multiple values at once. So if you did scanf with %d, which is an integer %d, and then anchor x, anchor y, I guess, address of, not anchor, and a C function can only return one thing. That's a new concept. A C function can only return one thing. I'm going to create a note here. I want to move my notes back out to the main thing because I don't want to split them. Session 2, temperature converter. C functions can only return one thing. It's a core learning. So it uses pointers to write multiple outputs. This write to an address pattern shows up everywhere in C. It's how functions communicate out parameters. Coming from JS, the closest analogy is passing an object and mutating it inside a function. Okay. All right. Math to convert and printf to display. So I'm going to go back and read it using scanf. So now we're reading that. Now we're going to convert it to Celsius. I don't know. I guess it's another double. Celsius temp equals. I would go my variable. I don't know if I need a pointer to it. My variable -32, and you would be times 5.0 divided by 9.0. And we're back. Sorry, I had to take a break. In the meantime, I have increased the font size here and in Claude Code as well. Okay, so we've got some linting, and I remember we need to declare this, which it only ever returns one thing, right? So it's going to return 0. So double Celsius temp. Okay. We're going to printf let's say the temperature in Celsius is percentage, no, I think it was what, df or something. Double is LF. Okay, so LF, in which we put, I'm guessing, look, it's a pointer, right? Because that's what happened the last time. Celsius temp. In direction requires pointer operand. Double is invalid for this. Okay. I don't know what that meant. But let's see. So what if I compile this now? And let's change the terminal font. Workspace settings. Oops. Settings. Terminal. Font. Let's make that 16 in user, 18 in workspace. Cool. So GCC. Now I forgot the command. GCC compile. Let's go cd to GCC compile temp.c. Did that do it? No. Okay. What's the compile command again? What I'm going to do is try to remember things and then get them wrong, because that's how the human brain actually learns. It's not being spoon-fed the answers. So GCC, okay. Warning all, warning extra, source file, and dash output temp. Cool. Now we're going to run ./temp. Temp, enter something, 100. Your temperature in Celsius is 37 degrees. I know that's accurate because I am in a Celsius country and 37 is about the human body, and I know that 100, maybe 98 is the Fahrenheit. So this kind of worked. Nice. I have questions though, like, so in, I think that worked, except we want a new line there. I want to know why did I not need a pointer when calculating Celsius, and also when printfing the Celsius temp. This gets at when, yes, that's what I'm asking, thanks Claude. Scanf needs a pointer because it has to write your variable. Does that make sense to me? Scanf needs a pointer because it has to write to your variable. Right, so scanf I'm guessing it takes whatever and then writes it to the variable. So when writing, you have to tell it the address and put data there. Without the pointer, scanf has no way to modify your variable. C passes everything by value, so the function would just get a copy of the number and any write would be lost. Math and printf only need to read the value. They don't need to modify your variable, so a plain copy is fine. So basically, when it's running this, like my variable here, when it's running this line, it's not actually accessing, well, it's creating a copy of whatever this is. They don't need to modify your variable, so plain copy is fine. The JS analogy, imagine every C function call is like doing that before using a deep copy. But it's interesting though, you'd think it's more efficient to just get the data from the address, right? Or I'm guessing it has to make a copy so as not to overwrite the variable. But couldn't it just read the data and keep it in memory? I don't understand why it's copying that. You're thinking about this in the right way. The answer is it is reading directly from the variable's memory address. The copy happens at the function call boundary, not as a protective measure. Okay, so when I actually call the print f, what the heck is this .2f anyway? The value gets copied onto the call stack, a chunk of memory used for function arguments. And then printf reads from the stack. Why copy onto the stack instead of just telling printf where the variable lives? A few reasons. It's how the CPU works. Function calling conventions, the rules for how functions receive arguments, are baked into the hardware architecture. Arguments go on the stack or into registers. Okay, so arguments go on the stack. Arguments don't go directly into memory. Okay. It's fast, copying 8 bytes. A double is essentially free. It's a single CPU instruction. Following a pointer to go read from another memory address can actually be slower due to cache misses. I don't understand this bit because doesn't it have to go find what the value is at the address before making a copy? It's simple and safe. The function can't accidentally corrupt the caller's data. How is it fast if it has to read the variable anyway, which lives in the address? You caught me being imprecise. You're right, it does have to read the address either way. Both paths are the same way. The CPU reads the value of Celsius temp from its memory address. Okay, so what it does is it reads value from the address. It puts it on the stack or in a register. Printf reads it from the stack. Okay. So I guess by putting it on the stack, that's what it means by copy. Pass by pointer hypothetical. Put the address on the stack. Printf reads the address from the stack. Printf follows. Okay. They both need access to the original memory. The difference is that passing by value does that read once up front and then the value is right there on the stack. Okay. Pointers start to when the data is large. Is there a limit to the stack? What happens when we exceed it? And I'm guessing it's a stack overflow. And I know that from the site, which no longer is functional, I guess. 8 megabytes of thread, you get a stack overflow. Yep. That's where the website name comes from. So each function call pushes a stack frame, space for its arguments, local variables. So the stack grows with deep recursion. Okay. The OS just kills it with a seg fault. I'm glad it doesn't just blue screen your whole OS. Okay, so this is how C programmers deal with huge stacks. I'm not going to bother with that right now, but what I'm going to do is write some notes. Okay, so when functions reference variables without needing to write. What does it do? The CPU reads from the address and copies the value into the stack. Okay. When you need to write to the variable, it needs the address. Use add. Okay, thanks. What's the difference between and this? You've used both for the pointer concept. Okay, they're opposites. Okay, so the and is the address of the variable, and the star thing is the value at the address. Okay, so if I declared temp equals 100, and then I said the value at pointer equals address of temp. Okay, so this pointer, the value of pointer. What? So pointer prints address. This is the what? What? First of all, I don't know what the %p and the %f is. So yeah, star has two different meanings depending on context. In a declaration, so double star ptr means pointer is a pointer to the double, defining the type. So it's not declaring ptr, it's declaring a pointer to the double. In an expression, star pointer means go read write the value at this address. Dereferencing. Okay. So what's up with instead of that? What's up with it? I don't understand. The star in the declaration is telling C the type of the variable. It's not an operation, it's part of the type name. So if I do double temp, which I've done here, double my variable here, this holds a double. Okay. If I did double the star pointer, pointer holds an address that points to a double. Yo, but you just told me and is for address. But now star is for address when declaring a variable? I think I have ADHD or something, or OCD. Here's the honest truth. Star is overloaded to mean different things in different contexts. It's one of C's roughest edges. Ah, okay, so it's just inconsistent. Three meanings. This means that pointer is a pointer type, a pointer to PTR, which is a double. Printf, if I use a substitution with start PTR, it dereferences, it says go read the value at this address. Double x equals 5 times 3, it's just math. And then this is the address. So they're opposite in context when used as operators in expression. Okay. The star and double blah 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 is completely different. It's not doing anything at runtime, it just sees syntax for declaring a pointer type. You could even read that as the thing pointer points to is a double. The thing the variable points to is a double. It's genuinely just bad syntax design from the 1970s. I don't know if Claude is qualified to say whether it's bad or not. Like, I don't think that you can just do that, but I guess it's trained on people's opinions, so a lot of people have this opinion. Many people wish C had done something like double at PTR or PTR double for pointer types to avoid the confusion. Rust actually fixed this. It uses a totally different syntax that doesn't reuse star. You'll get used to it, but the confusion you're feeling is 100% justified. Cool. All right. I'm going to rename this not that. Rename simple. Fahrenheit temp. And then save that. And is blah blah blah. Okay. I want to fix the formatting. So in my current code, the output is how do we why is there a percentage sign? I don't. I have this. Don't be lazy. Read the code. Don't be lazy. You're on high effort. What is it doing? Interesting, your code doesn't actually have a straight percentage. The format string on line 8 looks correct. What's... Okay, so we're seeing the terminal prompt. Okay, so we actually need a line break there. Okay, thanks. How do we print the little degree icon? And I just want to see if C has access to those weird symbols. You can put it directly in the string. Okay. Terminal and source file are both UTF-8. C doesn't care, just passes the bytes. All right. Let's do that. Fahrenheit temp. So enter Fahrenheit temperature you wish to convert. Enter the Fahrenheit temperature you wish to convert. Let's compile this again. And then run it again. And I want 98 degrees. Your temperature in Celsius is 36.666667 degrees. Cool. Okay, I think it's working. Review and see if I've missed anything. And I just want to check the plan again. Read input, do math, print result. I think that's it. For step 2. Covers everything the plan asks for. Scanf for input. Correct. Math is formula right. Oh yeah, what's this integer division thing? I wanted to ask it that. Variables and types. Double for both. Printf for output. A couple of optional polished things. Yes, what's this .2lf instead of lf? Limits to output. Oh, I would like that. I was wondering about that. So .2lf. And then handle bad input right now. If someone types ABC, scanf file it fails silently, and Fahrenheit temp is uninitialized. It's a garbage value, so we've declare it here, and then we never initialize it by writing to it. Okay. You can check scanf's return value turns 1 on success. Right. Okay. Okay. First of all, I want to know what is the difference between %.2lf and %.2f, which you have used as examples. What's the difference between those? I was inconsistent. Okay, this is what the heck. Here's why printf uses variadic arguments. And C automatically promotes float to double when passed to variadic functions. So printf only ever sees double. What? Scanf is different. Scanf does distinguish between them. %f reads into float. Percentage LF reads into double. Okay. What's variadic? It means the function accepts a variable number of arguments. Dude, how have I done software development for 10 years and I've never heard of this word. It means the function accepts a variable number of arguments. Granted, I didn't study this at uni, so it probably would have covered that. Printf can take 1, 3, or 10 args. Okay, so it's variadic. How do you pronounce it? Variadic. Variadic. Okay, it's variadic. Okay. All right. Let's work on the handling bad inputs. So you said the first thing is to check the output of scanf. So I guess it's like int result scan results equals that. Okay, so scanf returns the number of items it successfully read. So the basic check is if blah 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 is not equals 1. Well, I'm just declaring it into an integer scan result. If scan result, which is in the stack, so I don't need a pointer. If scan result does not equals 1, then we've got a problem, right? And I had to check and decide what to do if the input is bad. Okay, so I'm guessing like we printf error encountered. Could not read double type argument from the user's input, and then I would return 1. Okay, so let's try that again. Let's compile, run it again, and say ABC. Oh yeah, new line. So it returns 1. Cool. Can you check the code now? Also, what's the difference between returning 1 and 2? Looks good. Clean error handling, early return. Return 0 is success. 1 tells us shell something is wrong. The specific number is up to you. Some programs use different numbers for different errors. 1 is a bad input, 2 is file not found, 3 is permission denied, but for a small program like this, 1 for any error is perfectly fine. You can actually see the exit code after running your program. Echo $? 1. That's crazy. Wait, so where does it save that? Okay. This is how it's going. Okay, cool. Okay, so the exit code is the exit code of the last run program. Okay, it's the exit code of the most recently finished command. Okay, but what if I run a non-binary program after running my program? does the exit code get overwritten? Every command that finishes, regardless of what it is, a C binary, Python script. Right. Interesting. All right. Okay, so what have we learned? Pointers. And for address, star for value only when on right side of equals sign. All right, what else have we learned today? Return codes are custom, use whatever integer for whatever error type. Okay. Exit code. Codes. Echo $sign question mark. All right. Error. We did error handling. Error handling. Variadic functions are functions that take any number of arguments. Scanf and printf handle %lf differently, but we can just use %lf for consistency. Okay, what does lf stand for in %lf? Long float. A long float and a double. A double is literally double precision floating point number. The naming is a bit historical. Okay, so long D. So why is D int? Why is D integer? D stands for decimal base 10 integer. It's to distinguish from other integer formats. Hexadecimal integer, octal integer. All right. Percentage D is decimal integer. Contrast with percentage X for hexadecimal integer. Okay. Great. We also did maths. So, I need to know about integer division. Please now tell me about integer division. In C, when you divide two integers, the result is an integer, the decimal part is thrown away. Okay, so 5/9 instead of being 0.55. That's why your formula uses 5.0 over 9.0. If you'd written double blah blah blah, that would evaluate. Okay. If both operands are integer, C does integer division. If either is a float or a double, C promotes the other and does floating point division. Okay, so like if one of them is not an integer, then it does that. Okay. I must say though, I didn't really declare what 5.0 and 9.0 are. Do they just default to doubles? Yes, exactly. Number literals with a decimal point default to double in C. So why doesn't it default to float if a double is a longer float? Is it a precision thing or what? It's a pragmatic reason, double is the better default. Costs almost nothing extra on modern hardware. You get more precision. Float is kind of the oddball. It exists for cases where you need to save memory. Okay. All right. Use double or long float as default. Float is more for like embedded systems, etc. Or like performance concerns. Okay. All right. Well, today we've written something that takes a user input. We've done some maths around it. Sorry, we've taken the input and stored it against the memory address of a variable that we've defined. We've done error handling, and if we can't store this for any reason, we exit out with a return code of 1 and output an error. We then have calculated from the user's input the Celsius temperature, and we have given that back to the user. Awesome. This is step 2 done. I hope you enjoyed, and please join me for the next Let's Learn C. Thanks for watching.